Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Ah, Okay, so we have question 10. It says in an experiment, different light sources are shown onto the surface of an unknown metal. Then 10.1 says explain the term work function. Right. So what is work function? We say this is the minimum energy required to emit electrons from a metal surface. Right. Okay. So for 2 marks, that's how you are supposed to define work function. Easy peasy marks. Then, okay, 10.2 says electrons with a maximum kinetic energy of 1.2 times 10 to the exponent of negative 19 joules are emitted from the surface of the metal when ultraviolet light with a frequency of 6.3 times 10 to the exponent of 14 hertz is incident on it. Calculate the work function of the metal. Right. So in order to calculate that, this is 10.2 is E is equals to work function plus EK max. Right. So my E is H times F. Then we have work function plus the EK max, right? So we are looking for work function. We can substitute our Planck's constant, which is 6.63 times 10 to the exponent of negative 34. And then the frequency of the light, we've been told that it is 6.3 times 10 to the exponent of 14. And then work function, we are looking for that. And then our maximum kinetic energy is 1.2 times 10 to the exponent of negative 19 joules. Now at this point, we only need to multiply this and take this one over to this side. So you can quickly do that. Punch all of that into your calculator. You will get 2.98 times 10 to the exponent of negative 19 joules, right? So that's your work function right there for 4 marks. So that was just a giveaway. Then we have a 10.3, also another giveaway for 6 marks. Will electromagnetic radiation with a frequency of 3 times 10 to the exponent of 16 hertz emit electrons from the surface of this metal? Choose from yes or no. Support the answer with suitable calculations. So before we can choose yes or no, let's compare this frequency that we are given here with the threshold frequency of the metal. Right. So how can we calculate that? We already know that work function is equals to the Planck's constant minus multiplied by the threshold frequency. We already have calculated this from the previous question. It is 2.98 times 10 to the exponent of negative 19. Our Planck's constant, 6.63 times 10 to the exponent of negative 34. Then multiply that by the threshold frequency, and then we can divide both sides by this, right? So this was the most quickest option to deal with. There are still other options that you could have chosen. Could have chosen to calculate the energy of the photon and then compare it to the threshold frequency. Also, that one could have been an option. So we have threshold frequency is 4.49 times 10 to the exponent of 14 hertz, right? So note that this is the threshold frequency. So in comparison to this, we can see that the electromagnetic radiation has a greater frequency than the threshold frequency. So frequency of the light is greater than the threshold frequency, meaning we can then conclude and say, yes, electrons will be ejected, because remember, electrons are only ejected if a light of suitable frequency is shown onto the metal surface, right? So this suitable frequency is greater than the threshold frequency, right? So we're going to say yes, and the reason it's because frequency of radiation is greater than the threshold frequency. Than the threshold frequency. So if you've been wondering why it is 6 marks, it's because there is a mark for saying yes, there is a mark for concluding here, and then there is 4 marks for just the calculation, right? So that did not indicate the difficulty of the question. I always say do not look at the marks and assume that the questions are difficult. Then when the photoelectric effect is demonstrated, a negatively charged plate is used. Explain why, when ultraviolet light is shown on a positively charged plate, no charge is lost by the plate. Right, so for that one, we are just simply going to say the plate, as being indicated here, it's positive. So the plate is positive. So we know that if the plate is positive, that means it has more of the protons than the electrons. So it is electron deficient. So plate is positive, meaning that it has few electrons. So few electrons are available to be emitted or ejected by the UV light, by the ultraviolet light. So that means there is no change in charge of the plate. Will be observed. So no change in the charge of the plate will be observed. So that's it. So that's why they say when ultraviolet light is shown in a positively charged plate, no charge is lost by the plate. Remember, the function of the ultraviolet light is to emit the electrons. So since now there are few electrons to be emitted, that means we will observe no change, right? Because the ultraviolet light will not emit the protons, will not eject the protons from the metal surface. It ejects the electrons. So which is why we observe no change in the charge of the plate. Right, so that's how you were supposed to explain that for 3 marks. And then all of this question here was for a total of 15 marks. And then that was the end of your exam paper for Prelim 2024 Gauteng Province Physics Paper 1. So that's how you were supposed to go about answering all of those questions there. And then with all that being said, please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit the subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.